Finishing up our second part of the 7-3 Day 3 lesson, we're going to solve equations C and D. It says solve for values between 0 and 360 and give approximate solutions to the nearest tenth of a degree. Remember, this is a change from the note packet. So if you printed off the notes, originally this was all in radians on the back, and I switched it over to degree mode. I'm going to zoom in on example C just to give us some space to write here. 3 times tangent of 1/2 theta minus square root 3 equals 0. The first thing we do when we have a number with our theta symbol is we isolate the trig term, which means we want to isolate all of that. To do so, we need to move over the 3 and we need to move over the square root 3. Order of operations in kind of backwards mode, we would actually move the negative square root 3 over by adding it first. Then we have 3 times tangent 1/2 theta equals square root 3. To isolate the trig term now, just divide both sides by 3. And this is all step 1, isolating that trig term. Step 2, to get the theta term by itself, we take the inverse. To take the inverse, we would just get 1/2 theta on the left, and we would do tan inverse of, oops, I wrote square root 3 over 2. Sorry, I'll fix that quick. Hopefully you guys saw that and you put 3. That should be 3. And then we'll take tan inverse of that. Think to yourselves, unit circle or not unit circle? Tangent's not quite as common as sine and cosine. However, square root 3 over 3 is in fact a unit circle friendly location. And you are welcome to write tangent values if you have other notebooks or if you want to just calculate them on your unit circle to have as reference. This would be one of those situations where it would pay off. On the unit circle, tangent equals square root 3 over 3 in quadrants 1 and 3, close to the x-axis. In quadrant 1, tangent equals square root 3 over 3 at 30 degrees. And in quadrant, I almost said 4, in quadrant 3, it's at 210 degrees. Then we look at our b value. Notice b equals 1/2. And if that's between 0 and 1, which obviously it is, we don't have to find coterminal values. We can now go to our last step from here. If we want to get theta by itself, we need to get rid of the 1/2. So I'm just going to multiply it by the reciprocal, 2 over 1. And that means I need to double both of my angles on the right-hand side. If we double 30, we get 60. But if we double 210, we get 420 degrees. Those would technically be our two answers. However, when we look at our restrictions, remember the rule is you have to be between 0 and 360 degrees. That's our restriction in the directions. Because of that, 420 degrees goes beyond that limit. Therefore, 60 is our only solution in problem C. Our final example, example D. 5 times cosine 3 theta is equal to -2. Now we know this follows our day 3 rules due to that coefficient in front of theta. Our first step then is to isolate our entire trig term, which would be 3 cosine theta, by moving 5 to the other side. To do that, we'll divide, leaving us with our cosine 3 theta on the left and -2/5 on the right. To get 3 theta by itself, we're going to take the inverse of the other side. Now 2/5 isn't one of our unit circle friendly locations, therefore we need to plug this into our calculator. And make sure your calculator is in degree mode. If you type in cosine inverse to the nearest tenth for -2/5, you would get 113.6 degrees. Now to get cosine's second answer, we subtract that from 360. And that would give us 246.4 degrees. That means those are the two values where cosine is equal to negative 2/5. 3 theta will equal both of those. Due to the fact that b equals 3, that's greater than 1, what we need to do is have 3 sets of values that are coterminal with the locations at 113.6 and 246.4. I'm going to add 360 to both of them. And that will give me a second set, and then we'll add 360 to those, and that will give us our third set. So we have to have 6 total answers in this row. Oh boy. If we take 113.6 and add 360 to that, we're going to get 473.6. And if we take 246.4 and add 360, we'll get 606.4 degrees. And now I have to add 360 to both of those for one more set of coterminal values. If we take 473.6 and add 360, we get 833.6. And last but not least, 606.4 plus 360 would give us 966.4 degrees. Those are really big angles. But remember, we're not quite done solving for theta. Our last step in getting theta by itself is dividing the b value to the other side. Here's where we make everything significantly smaller, and we divide them all by 3. So what I want you to do right now is grab your calculator, please pause the video, divide all of these answers by 3. When you're done, every problem or every solution needs to be between 0 and 360. So then press play and we'll see how it went. When I divided everything by 3, I got values as little as 37.9 degrees all the way up to 322.1 degrees. All 6 of those theta values make our equation in D a true statement. That will be the end of your notes for Chapter 7b, which is essentially just Lesson 7.3. That's a lot of content. Please work on your 7.3 Day 3 assignment today and submit when you're finished.